Welcome back. In your last lesson, you reviewed right angle trigonometry, and today we're going to review the sine law. The sine law, of course, can be used when you have a non-right triangle in order to find the length of a missing side or the measure of a missing angle. And in order to use the sine law, you first need to be either be given or be able to find the measure of one of the angles in your triangle as well as the length of the corresponding side to that angle, the side across from that angle. So looking at this first example, that's exactly what we do have. We are given the measure of angle A as well as the length of side A. So that's what tells us that we can use the sine law to approach this question. Now the question is asking us to solve the triangle. So let's remember that solving the triangle means to find all missing measurements. So since I'm also given the length of side B in this triangle, we could use the sine law to begin with to find the measure of angle B. Now notice there are two versions of the sine law given at the top of your page. They both work all of the time, but it's suggested that if you're finding the measure of a missing angle, you'll use the version that has the angles in the numerator of the formula. That would be this one. And if you're finding the length of a missing side, you will use this alternate version which has the side lengths in the numerators. Okay, however, having said that, they both do work for any question, so it really doesn't matter. It just makes the steps in the middle a little bit easier if you follow that advice, okay? So back to what we were saying, we are trying to find, first off, the measure of angle B in this triangle in example 1. So we're going to set this up as follows. Since it's angle B I'm looking for, the first thing I'm going to write down is sine B. Now using the sine law, I would have to say sine B over B is equal to sine A over A. And I don't need the remainder of that formula at this point. So I'm going to plug in the information that's given. So we're given the length of side B, which is 16, and we're given angle A, 95 degrees, and side A, which has a length of 27. Okay, we're trying to solve for angle B, so at this point I'm going to isolate the sine B, and in order to do that I'm going to multiply both sides of this equation by 16. So on the left hand side we'll be left with just sine B. And over here, when we multiply on this side by 16, we're going to, of course, multiply the numerator by 16. So it will be 16 sine 95 divided by 27. Now remember, when you type this into your calculator, leave the decimal value on your screen and use your inverse sine button to find the angle. And you should get an answer of 36 degrees. So let's just make a side note here so you don't forget. Use sine inverse to find B. And by now you should have figured out how your calculator works to accomplish that, but just in case, bring your calculator to me if you need some help. Okay, so we found the measure of angle B. Now we're asked to solve the triangle, so we also need to find the measure of angle C. That's much easier because now I know the measures of the other two angles. Okay, so let's number this so we don't get confused later. So here's the first thing we did. Now we're going to find the measure of angle C. And of course we know the angles in a triangle add up to 180 degrees. So we can find the measure of angle C by subtracting the known angles from 180. So 180 minus 95. Minus 36, that should say, tells us that angle C is about 49 degrees. Okay, and lastly, we need to find the length of side C. So this is where I could use the sine law again, because now I have the angle C. So since it's side C that I'm finding, write that down first, then fill in the formula. So it will be C over sine C equals. Now I could use either B and angle B or A and angle A. I would recommend using the information that was given in the question, because had we made a mistake in step 1 when we were finding angle B, now if I use that angle again, it's going to mess up this step as well. So when you have a choice, I would recommend using the given information. So we're going to use A and sine A again. Okay, so then we'll sub our known information into this formula. So we know that the measure of angle C now is 49 degrees. And of course we know that the length of side A is 27 and the length of angle A is sine 95 degrees. And of course the reason I'm using the alternate version of the formula is because we're looking for a side length, okay, just to reiterate that. Now from this point we solve in a similar way though. We're trying to isolate the C in this equation. So we're going to multiply both sides by sine 49 degrees, which would leave just C on the left-hand side. And in order to multiply by sine 49 degrees on the right-hand side, we're going to be actually multiplying that in the numerator. Okay, we type that into the calculator, and we find out that the length of side C is 20.5. There's no units given in the question, so we'll just leave it like that. Okay, moving along to the next example. In example 2, we're asked to find the measure of angle X. So since we're asked to find the measure of a missing angle, we will use the version of the formula that has the angles in the numerator. So we will say sine X over 12, since 12 is the opposite side, okay, equals sine 40 over 8, since those are across from each other. Okay, to get sine x by itself, we'll multiply by 12 on both sides of the equation. And then again, to find angle x, you will use the second function button on your calculator, the sine inverse function, to arrive at your angle measure. And we'll round to the nearest degree, so it's approximately 75 degrees. Okay, so far that should all seem familiar to you. Most of you have seen, or all of you should have seen the sine law before. What likely is new to most, if not all of you, is the ambiguous case when dealing with the sine law. I'm not sure if you would have talked about that last year or not. Sometimes it's possible when you're given the measurements of a triangle, or some of the measurements in a triangle, and you're asked to solve said triangle, it's sometimes possible to draw the triangle more than one way to satisfy the given criteria. In other words, there is sometimes more than one solution possible. So I've given you an example of that here. It says, suppose you were asked to solve triangle ABC, where A is 36 degrees, side A is 5.9 centimeters, and side B is 7.8 centimeters. Now, of course, a good starting point would always be to draw the triangle, but the thing is, there are two ways I could draw this triangle. Okay, so I could draw this as sort of an acute triangle. So I could say this is triangle ACB. And in this triangle, angle A is 36 degrees. And the side across from it is 5.9 centimeters. And side B is 7.8 centimeters. Okay, that would be centimeters. That would be one way I could draw the triangle. But I could interpret this a little bit differently, and with the same measurements, I could create the triangle like this and say this is triangle ABC. This is still 7.8 centimeters, 36 degrees, and 5.9 centimeters here. So you can see that both of those triangles would satisfy the given criteria. When that happens, we have to be careful in our solution because there are actually two solutions which are possible. Now I'm going to show you those solutions, but at this point I would like you to stop this video and go to the video part 2, please.